Guys, before we leave, I want to congratulate Ronak because she got a ranking about for in a part of Saudi Arabia, which is eastern part Saudi Arabia, was the third place in physics. That really makes me proud, and we mentioned your name many times in our meetings today and yesterday. So thank you very much, and keep the good working. And inshallah, Allah bless you. And I hope that happens for all of you. You still have a chance during this session to get this ranking, and it will be a great memory for you and for your kids after that, and even for your kids. Try to do your efforts and remember in Allah subhanahu, if you spend more time and if you work hard in something, there is some secrets. Even without teachers, you can reach to it. Even without any help from anyone. Once when you spend more time in something, there is some secrets. Maybe the teacher didn't tell you about it because he forgot this, or maybe it's not in the flowing of talking, but at least Allah will open these secrets for you, and you can do these things when it comes to science easier than the rest. So try to press yourself, encourage yourself, whatever the mean is. Give yourself some, what should I say, some gifts about the time and about the great future that may be waiting you. And inshallah, for all of you to get this ranking in this session. Thank you, guys. If you have a question, you can ask. If you don't have a question, you can leave. Thank you.
Sir,
Yes.
thank you so much. You are amazing. Thank you. It means a lot to me.
Thank you. Thank you. Great. It's recorded, by the way, and I will share this part.
Thank you. Bye, sir.
Okay, bye. Thank you. Students is investigating how the extension E of an elastic cord depends on the diameter D of the cord when a force is applied. You know, this is related to not Hooke's law, clearly, but it's part of Hooke's law. And as you know, the young modules that we studied before in AS, young modules equals stress divided by strain. Just a reminder, young modules is equal to stress divided by strain. Stress itself, it was force divided by cross-sectional area. Strain divided by strain, it means divided by delta L over the original length. So I'm gonna cancel the original length from the denominator of that denominator and kick it up. So this is exactly the law to find the young modules, and I think it's written here. And they said the students has a number of elastic cords, all of them made from the same material but with different diameters. The elastic cords have a circular cross section. Each cord has an unstretched length of approximately 50 centimeters. So we have many information like 50 centimeter here, it's L, because this L, it's not the length as it is the original length. So strain, it was delta L in AS when we studied it. It was the change in length divided by length. When I mean the length here in the denominator, it means the original length. There is no total length should be applied in our calculation at all. So strain, once again, equal delta L divided by L. When I mention L, when it comes to young modules, that means it's the original length. It's not the total length, including the extension. It's just the original length. Then it's suggested that the extension E and the cross-sectional area A of the cord are related by this expression, where E is the young modules of the material of the cord, F is the force applied, and L is the unstretched length of the cord, which we call it original length. Design a laboratory experiment to test the relationship between E and D. E here is the extension, D here is the diameter. As you see, there is no diameter in the law, but they mentioned A. We can just change a little in the law to make D appear in the equation itself by applying D divided by 2. This is the radius. Radius is very important when it comes to the area. Then explain how your results could be used to determine a value of E. So we need to find the value of E. We will draw a relation between two variables. I'm going to change them, which is E and D. And depending on this relation, we could find out how could we find E. Anyway, you should draw a diagram on page 3 showing the arrangement of your equipment. In your account, you should pay particular attention to the procedures to be followed. Yeah, need the steps, the measurements to be taken. We need to mention every single measurements that we need to take. Like, for example, the diameter. We need to use a micrometer in order to measure the diameter of each elastic cord, and meter rule to measure its length, and maybe balance to measure the mass of the load. Then this mass multiplied by the gravity acceleration, it could give you F if we vary F. If F were constant, we need to mention even, and we are using a balance To know the load, then we can find F depending on mass multiplied by gravity acceleration. I'm just discussing with you before we start. Then we need to mention the control variables. Something should be stays constant during the experiment in order to make that the experiment is fair. Like maybe, in my opinion, we're gonna change the cross-sectional area and mention the extension and find the extension. So the extension may be changed because it is independent. Sorry, it is a dependent variable, and we need to change ourselves. We need to change by myself. I need to change by myself the cross-sectional area by using different cross-sectional area, or by using different diameter. And during this experiment, something should be stays constant, like F, L should be stays constant. Both of them. The force should be stays constant in order to make that. And the only thing could be changed is the diameter, and we will see the effect of that on the extension. And also L, I mean the original length of each elastic cord, it should be the same, because by changing L, the extension itself could increase or decrease. So both these F and L should be stays constant. Let me write that here, F, L. Then the analysis of data, as usual, we need to mention something about the equation, then the table of data, then the graph. Any safety precaution to be taken in such this experiment, use Google. It's very effective, especially in the stretching elastic cord. It could jump out and throw something, throw air, and that could be cause any effect in the eye, or it could be cause any dangerous for eyes. So use goggles here is very effective. بس خلاص, this is what exactly we need to do in experiment 1. Let me start. I'll go through the figure. As you see here, they said we need to design a laboratory experiment to test the relationship between E and D. E here is the extension, D here is the diameter. So initially I will draw the diagram like clamp. Then over this clamp we have a holder, and from that clamp we have the elastic cord. So I'm gonna draw it this way. Looks like a cord. Then by the end of it, I'm gonna attach a load, right? And beside it we have a ruler, and it's a good idea to attach a pointer over this ruler. So we have 2 pointers, one of them in that point and the other is in that point. Then I'm gonna write the labels then, and it's a good idea to attach another holder here for the ruler itself. So write the labels. This is stand, this is clamp, and we have a ruler. So this is a ruler. This is the load, and that way we called it elastic cord. Elastic cord. And also we have a micrometer. This micrometer could help to measure the diameter of the wire itself. So I'm gonna write micrometer to measure the diameter, or to measure D. D here is to find the area. Okay, we will mention that in below. خلاص, I have figured. I have finished. This is the figure. Now let's start with the explanation. طيب, as you know, number 1, fix the tools as shown. Fix the tools as shown. 2, use the ruler to measure the unstretched length of cord 1, the unstretched length of cord 1, and I'm gonna give it a title which is L. So this could be stays constant during the experiment. Number 3, add the load F, or hang the load F. Hang will be much better. Hang the load F on the cord 1 and find the new length. Then find the extension. They give the extension a symbol here, which is E. Find the extension. Find E by applying that E equal to the new length minus L minus L. So now I have the extension. Then the next step, we need to use another cord with different diameter, right? But before we go there, number 4, use a micrometer to find the diameter for the cord. Anyway, we mentioned that before in our explanation. Right, use the micrometer to find the D for the cord 1. Number 5, now I'm going to change. And once when we change, make sure that the variables or some variables should be stays constant, or some conditions should be stays constant. Like, I'm going to say here, change cord 1 by cord 2, which has the same length, the same L, but different diameter, different D. Number 6, hang the same F, this is very important, the same F on cord 2 and find the new extension or new length, then the new extension. For the cord. Number 7, what we need to do here is just keep changing the chords until we have at least all the chords should be used. So repeat or do the same steps. I mean step 2 and 3, step 2 and 3 and 4 until we have all the chords. We mentioned everything about the length of the chord. It should be the same. It's written here, the chord 2, which has the same length but different diameter. And also we mentioned that it should be the same F should be applied. Hang the load F on the chord. Then I say here had the same F. So we mentioned these 2 points. Hang the same F, and we mentioned here it's the same L. So these are the conditions should be stays constant during the experiment. Then they said we have all the until we have all the chords. Number 8, arrange the data in a table. Now, before applying the table itself, let me write all data in the table that we could use. I'm not sure if we're going to use them all or not, but anyway, this is the number of trial. Then we need to X is constant, L is constant, F is constant, so no need to mention them in the table since they are the same for all trials. But many things could be changed, like if the diameter which measured in, let's say, millimeter or centimeter, it doesn't make any difference. I'm gonna write here in millimeter. Then also we could need the radius in order to find the area. So that means diameter divided by 2, it gives you the radius also measured in millimeter. And once when I know the radius, I could find the area. So I'm going to write here the area measured in millimeter square. Millimeter square. So millimeter square. This is for the area. And since the area will change and we still have only the extension, then I'm gonna write the extension here measured in, let's make it millimeter also. Let's to have it all millimeter. Keep in mind, we're gonna draw a relation or find a relation between this A and this E. Is it? You check in the question here. Design a laboratory experiment to test the relation between E and D. E and D. So let's go back here. E and D. So it could be E and D. So I'll make it D and E. Right? D and... So we will remove A from the law itself. A is not important here. So we're going to change the law. But let's see. Since the equation, now we have finished. So number 9, I'm going to write since. The equation is Young modules equal to F over A. Then here we have E. This is E divided by L. Okay. So since this is the law, that law could be changed to be FL, we have them, divided by, instead of area, I'm going to use the diameter. So since the area could be measured by R squared, so I'm going to write here diameter divided by 2 square. So this is the diameter square. And here we have pi divided by 2 to find the area. It means divided by 2 square. So I'm going to write here 4. So this is exactly the law. Should I repeat this part? Just take your time on this. Once again, I could say F divided by the area, then E over L. So that's why we have L in the denominator, right? So instead of area, I will just change this to be by R square. R, its diameter divided by 2, then square, and we have pi here, right? Then we still have E, the extension, right? So this law will be changed into D divided by 2 itself. It means the radius. So I'm going to keep D because they ask you to find the relation between D and E. So I'm going to keep them both in the equation. So this equation mathematically could be changed into the same F, the same L. I have both, then divided by. By is there, D square over 4. I will write 4 here. Then we have E, right? This is what I need. So once when you need to find a relation between D and E, we could use this fact. I'm going to use here. It's this is E and this is D square, right? Now let's find the relation. How could we draw it? So if you rearrange the equation again to make D in a side and E in a side for the straight line equation as usual. So I could say after cross multiplication E or by E D square E equal to 4FL. Right? That means, when I transfer E to the other side, that means D square, let's say D square equal to, I transfer the rest to the other side, it's 4FL, then divided by E, and here we have E. So now I can draw a relation between D square and 1 over E. D square and 1 over E. So this is very effective if we change this equation to be D square equal to, we're going to say multiply by 1 over E. This is the x-axis, and here we have 4F divided by E. Okay, so this is the same equation. Now I'm going to draw the relation to show, draw the graph to show the relation, which is, in the graph, I will consider D square, its y-axis, measured by millimeter or whatever, measured by millimeter. And I will write 1 over E here, measured by, again, millimeter minus 1. And the graph, as you see, it could be straight line passing through the origin because we don't have any y-intercept. Like I can consider, this is plus 0, so y-intercept here will be 0. So my graph is supposed to be straight line passing through the origin. Best. Then we could find the relation, which is the slope, because they said here, the question mainly was design allometric experiment to test the relation between E and D. We just did. Explain how your results could be used to determine the value of E. Okay, let's go there and find the value of E from that equation. So the slope from the graph, we can find that the slope equal, or the gradient equal to D square divided by 1 over E, which is E itself, right? So this is the slope. And from our main equation, we could find D square multiplied by E could equal, from the equation, E equal, be careful in this, I'm going to say E equal 4FL divided by D square, or by D square E. No need to mention D square E here, and instead of D square E, I will write the slope. This is how to get the necessary information in order to find E, because they ask you, how could your experiment help to find the value of E? So E, according to the steps and according to this graph, it could be 4FL divided by the gradient multiplied by pi. This is exactly E, right, from the equation itself. Remember, the slope, as we mentioned in the previous one, equal D square over E. And I got this relation from the graph. بس خلاص. طيب, we did the data analysis, we put the variables, let's try them one by one. The procedures to be followed, we did. The measurements to be taken, we wrote that using ruler, and for the extension and using balance to measure F, did we? Hang the load F. We didn't mention the balance here, I could mention it here. Use balance to find the mass of the load and apply F equal mass times gravity acceleration. So now we have F is ready, and find the new length. Find E by applying this. Use a micrometer to find. خلاص. Change the code type. The measurements to be taken, the control variables, we mentioned them, and F should be stays constant, and even L should be stays constant during the experiment. The analysis of data, the work for the equation and the data of the table, in addition to the graph. Any safety precautions to be taken, we need to write that by the end. It's a good idea to use goggles to avoid or to protect our eyes. So number 10 here, we could write use goggles to protect our eyes. Yes, خلاص. This is what we need to write in such these experiment. Any comments, يا باشمهندسين?
Sir,
Any
can you
comment?
go up so I can see the apparatus? I just want to copy it.
I'll send you this paper once when I finish it.
ماشي تمام.
You need to read the labels carefully in order to get the full mark in the figure, because they ask you to draw a diagram. So once when you draw the diagram, there is no diagram in physics without labels. So you need to write the labels carefully. If you want to add pos beside the clamp, it's fine, but without pos, just write the clamp and stand. It could work. Meter rule and the load and the elastic cord.
Thank you.
Okay, that was for question 1, and it's easy, but it has many details in order to get the 15 marks for question 1. So please remember as much as you can from the details itself. Everything mentioned should be, you should mention how you measure it, how you calculate it, how you find it, how you get the use of it. So you need to write everything you remember. Please write it. This is for question 1. Let's go to question 2. In question 2, if you remember, no, not you. We didn't study that yet. This is about wave student investigate the monochromatic light passing through a double slit. We will complete studying this factor in the duality of waves this year. We didn't start it yet. Maybe 2 units before the last one, before space. The duality of waves. When the wave passing through a narrow gap, it could diffract. And the diffraction means we have fringes, then dark spots, fringes, then dark spots, and so on. So this is an image over a screen. On the back of the screen, show you exactly the points or the difference between the fringe slits, or the fringe spots, and the dark spots. And they have a distance between one of these fringes to the other one, and that distance has been shown as W. Just a kind of reminder, because we're going to use it this year in a chapter about duality of waves when we answer the question, is light wave or particles? So let's see and remember what we already studied before. Imagine we have a single slit here, a double slit here. So we have 2 gaps or 2 slits, and there is a source of light. And let's consider easily, that source of light, it looks like an electric bulb. And the electric bulb sending the 2 slits, S1 and S2, the same amount of light, the same direction, the same quantity or the same energy of light. In front of that double slit, we have a screen, and I told you before, the light could pass through S1 and be accumulated in this part, and the light also could be accumulated in the same point. So here we have a fringe, and we describe this fringe as it is n equal 1. Exactly in the midpoint, if you remember that from AS, exactly in the midpoint, we have fringe, dark fringe. This is called dark. So here we have D, means dark, and this is n equals 0, right? If you go further, if you go up, you will have another dark spot, then another fringe spot, then and so on. So every time after N1, some dark space, then N2, then N3, then N4, and so on, up and down. So again, down, we have the same design, right? Now we're gonna take an image. So imagine, this is my camera right now. So I will take an image for the back of that screen. I will see the fringe and the, so this is fringe is very brighty, and the dark part starting from below the fringe until I reach here. Then I will have another fringe and so on. So that part, it's exactly shown in the screen as that part. So I have fringe, then I have fringe, then in between I have dark parts. Even through our studies this year, we will realize that electrons also, like light, it can diffract. And this is what described by one of the scientists, his name is Gerber, I think. He said, even electrons could diffract. So the electrons, it has some properties like waves. And he enlarges the idea, and he starts calculate the wavelength for the electrons, depending on this law. He used the experiment, but instead of using light, he used a source of electrons, like a third ray oscilloscope. And he realized that even electrons, it has a wavelength. And if it has a wavelength, it means it has a frequency. And the area becomes larger, because some people said, even human being, they have inside their bodies electrons. That means, the entire human being, it has a wave. And that means, each one of us right now, we looks like waves in some properties, and each one of us has a frequency and has a wavelength. But we cannot observe it because they're very, very small. So you cannot observe them. We didn't reach that technology to find the wavelength for a man is running, for example, right? But we will study that in the duality of waves in few classes coming. Now forget about this. This is what we study already in AS, and back to that image. Actually, this is the back of the screen, and they said, and if you remember, I forgot something about the equation. If you remember, we mentioned a line. We did draw a line between this point and that point, and we said that line it has an angle here which is 90. And this is called the path different. I'm not sure if you still remember this in AS or not, but it was very close a few months back. The path different, it is the difference between these two pathways, yeah, Sada, right? So that pathway is longer than the other one by this path different. And the path different itself could be calculated by, the path different equal to n, I mean, for n1 or n2 or n3, then multiply by the wavelength, right? So this is the path different. And also we have the same angle. I have two angles here that are very, very close to each other, and they are almost equal. This angle is theta, and again, that angle is theta, this one. So we have another theta here. These two angles are equal. So if you apply the rule of sine and cosine for the red theta, so this is the red theta. So I'm going to write here for the red theta, so theta or tan theta equal to the opposite. The opposite is the half the distance between F and the other F, right? So I'm going to write here, it is the distance between two successive frames. So let's say this is D, for example. Then divided by the distance between the double slit and the screen. That distance represented by D capital. So I'm going to say divided by D capital. Forget about this. Now let's back to the blue theta. In blue theta, this one, this is the blue theta. Blue theta itself equal to, sorry, this, not this one. Let me highlight it in a proper way. I mean that one. This one exactly here. We have the blue theta. Blue theta, I could use the idea of sine. So it could be sine the opposite, which is P, the path different, divided by the adjacent, which is the distance between the two slits. So let's say this distance is A here, right? Sine theta and tan theta for a very small angles, they are almost the same. So we can write D divided by D capital equal P divided by A. Actually, this law, this is what we have here. After changing the path different, after changing this path different by n wavelength. So n wavelength, n here is equal to 1. So I need to mention it. So keep it just wavelength. So the wavelength divided by A, I wrote it A, but that A, it is the distance between two slits. And this is what they describe it here by S. And equal to D divided by D capital. D capital here, it is the distance between the screen and the double slit. And, D small, when I wrote it here, I mean the distance between two successive frames. And this is exactly what we have here, right? This is the distance between two successive frames. We can find the distance between two successive frames by applying W divided by how many frames that we have. We will back to this. Anyway, I just use this to remind you, but by what we study in AS, and we're going to use it again in duality of waves this year. Let's go to the question and just take some rest. We will finish the first page, then we will stop for 5 minutes for Maghrib prayer, then we will back. They said here, students investigating the monochromatic light passing through a double slit, bright and dark frames are produced on a screen as shown in figure 2.1. The distance W between 10 bright frames. So we can find, that distance between two successive frames, it could be represented by P here equal W divided by 10. This is the distance between two successive frames. So I'm going to say here the distance W between 10 bright frames is measured. The frames spacing P between neighboring light frames is then determined. Okay, we can determine that by, that P equal to W divided by 10. Very good to go. The experiment is repeated for light of different wavelength. And they said it's just suggested that the frame spacing P and the wavelength are related by this equation, wherein that D, it is the distance between the double slit and the screen, as we drew few seconds back, and S, it is the slit separation, the distance between S1 and S2. A graph is plotted of P on the y-axis against wavelength on the x-axis, determine the expression for the gradient. So let's see, this is very easy equation, so I could use this. They told you can use the draft paper or the blank paper to write this. They said here P in y-axis and wavelength in x-axis. So there is a graph between them. and they said determine the expression for the gradient. I know the gradient, it could be P divided by wavelength. So that will be D divided by S. So since P over D equal lambda divided by S, that means P over lambda equal D divided by S. So once again, P divided by lambda, it could give you D divided by S. Mathematically, it's correct once when you do cross multiplication ID, right? So I got down here and I could write the gradient could be represented by D divided by S. That was very easy, and any students got this first mark. Now on the second page, and this takes a little time, they said the values for lambda and W are given in this equation. So you don't need to find that W. They find it for you from the figure. Once when we have that wavelength, so the distance between two successive frames could be represented by that W. So I gotta say, the wavelength has been increased, and depending on that W, the spacing will also increase. Right? And that gives you an idea about P, and they ask you to find P. So calculate and record the values of P in figure 2.2. Remember, that P from this equation equal W divided by 10. So what I'm going to do here, so the answer will be 3.95. And for this one, again, W divided by 10 gives you 4.35. Then I have 4.80. Then I have 5.20. Then I have 5.55, then I have 5.90. I did the calculation when it comes to P equal W divided by 10. That was easy. And I gotta say, plot the graph, include the absolute uncertainty. Remember, the uncertainty here, what is that? They didn't give us the uncertainty. Positive or negative 0.5. So in order to do so, I'm going to use this idea, and I said divided by 10, divided by 10, divided by 10, divided by 10 for all of them. And 10 here, it has no uncertainty. It cannot be 10.5, it cannot be 11, it cannot be 9.5, even it cannot be 9. So since, we took the number divided by a constant number, so the uncertainty for the product should be the same as the original number, right? So I'm going to keep that as it is. I will say, instead of using 39.5 divided by 10, which has an uncertainty 0.5. So when I take the maximum divided by 10, that means that 0.5 also will be divided by 10. So I could write positive or negative, then take the uncertainty here and make it 0.05. The results of 0.5 divided by 10. It's the same ratio. If you change it into percentage, it's exactly the same, right? So 0.5 as a percentage has been taken from 39.5. It could be as 0.05 as a percentage taken from 3.95. And I could apply that for all of them. That was easy. So positive or negative, again, 0.5 divided by 10 gives you 0.05. Then positive or negative, 0.05. Then positive or negative, 0.05. And so on for the rest, unless if it was different. Right, so the first step is change it into percentage form, then take the same percentage out of the product, right? So check 0.5. This is the step in details just to understand it. 0.5 divided by 39.5, multiply by 100, it gives you a percentage. Take the same percentage from the product P, from 3.95. You will find it should be the same ratio, 0.05, 0.05 for the rest, since the original number was 0.5. So we have finished this, and they said here plot a graph of P measured in millimeter against lambda multiplied by 10 power negative 7 meter, include the error bars for P. P in millimeter against lambda. Oh yeah, against that one. Okay, they draw it, and the uncertainty will be given as an uncertainty bars in the graph. Okay, let's go there. They wrote everything for you, and as usual, we will draw two lines or two graphs: the worst line and the best fit line. We will make that after 5 minutes for Maghrib prayer. Then we will back. Okay, just 5 minutes. Then we will back to the graph. I think you will be faster than me, and when it comes to drawing, but we will draw together. They said. Do the calculation and record the value with the uncertainty for P. We did. The same plot a graph P measure the millimeter against. Everything is ready in the graph. Then we're gonna, as usual, draw the straight line for the best fit and the worst acceptable straight line. You can find the most steeper or the less steeper. Any one of them, it's up to you. This is your free choose, but just draw one worst line. No need to draw both. It will confuse you. And even the intersect point, it will be not that much clear for the best fit graph. So draw just one, because you requested to draw one worst line and one best fit. Then after that, we will do the calculation. As usual, I'll take an image, then I'll start draw. Please, you could start, because actually you'll be faster than me. So clearly, this is the points that I have. It seems in all of them on one straight line. The uncertainty for B is 0.05 for all. I can feel that in each 4 divisions. So this is 10 divided by 2 each. So this is 8. This is 5.9. So that means in each one division represents 0.02. Yeah. Yes, 0.02. So 0.05, that means 0.05, it's located somewhere here. 2 divisions and a half. 2 divisions and a half for each one of them. So 2 divisions and a half. Approximately. Two divisions and a half. 2 divisions and a half. For me, I will draw in 2 colors, but you don't have to do that. I will use red for the worst line. Just make sure that the line at least in touch with the point or with its uncertainty. This is the worst acceptable line, and I will draw the best fit line in blue, which passing among most of the points. You need to label them as they ask you. So I'm gonna choose this point. This is the best fit line, and here this is the worst line. بس خلاص. Is what you draw, يا سادة, was similar like this? Guys, have you finished? Hello.
Sir, I'm done.
I'm expecting I'm the slowest one here in the class, because
Yes, sir. I'm also done.
Okay, fine. Is it the similar, or did I do anything wrong?
Sir, mine is similar.
Right, that's great. So let's go here. This calculation, I will not do it, but I'll guide you. Just a reminder, after drawing the best fit line and the worst acceptable straight line, determine the gradient of the line of the best fit, include the absolute uncertainty in your answer. So in this case, we have 3 steps. The first step is find the gradient for the best fit. Changing y divided by changing x for the best fit. Then the second step, find the gradient for the worst line. Once when you find both, that means the change in G, it's equal to the uncertainty, right? So I'm waiting for you to tell me what's the best fit gradient and what's the worst line gradient, and what is the difference between them. Keep in mind, you have that in millimeter, and you have here times 10 power, let me erase this, times 10 power negative 7 meter. So it is a good idea to change that millimeter, the reading here in x-axis, sorry, in y-axis, into meter. How can I apply this? By changing it into P, measured by times 10 power negative 3, then meter. I hope it's clear. I just changed the word milli into times 10 power negative 3 in your calculation. So whatever the reading for B, whatever the reading for y-axis, it could be multiplied by negative 10 power negative 3 in order to change it into meter, and keep that into meter also. By this way, the slope will have no measuring unit, right? So keep that in mind. The gradient is just a ratio, so it will have no measuring unit in such these cases. The wavelength is a distance, p, it is also distance, so it has no measuring unit if the two measuring units were equivalent, both of them in meter. So please go through this one. Just choose any 2 points, and also you need to show you're working on the graph paper itself. So I will choose this point for myself, for example, on the best fit line, which is easy for me to take a reading, and I will choose maybe this point. Any 2 points in the graph away from each other, then draw the triangle. This is for the best fit. Then for the worst acceptable line, so what you have to do is choose any other 2 points. Like for me, I'm gonna choose this point. Because it's easy to read, and also this point. Any 2 points away from each other to find the slope for the two graphs. Yes, once when you finish, let me know what your value, like what's the gradient for the best fit, and what's the gradient for the worst line.
Mister, do we have to convert it when we're doing the gradients, like millimeters to meters?
Yes, to make sure that there is no measuring unit. Using the ratio, it's much better in the coming few pages.
Okay.
Yeah, and instead of use millimeter over meter, that means there is a measuring unit, or there is a difference in ratio, right? So it's better to make millimeter as meter, so they're gonna cancel each other completely, and that means you have just the ratio in the equation. That will make your life easier.
Sure, but the best fit gradient is 1.25 times 10 power negative 4.
1.25 times 10 power
Negative 4.
Okay, that will be in meter, and for the worst line.
No, I'm still getting.
Sir,
Mm-hmm.
for the gradient of best fit, I got something completely different. I got 8,000 because I also multiplied by 10 to the power negative 7 on the denominator. Should we divide?
That makes more sense. So let's do what I did choose. That makes Omar, that makes more sense because 10 power negative 3 will be get cancelled by 10 power negative 3. Then the rest 10 power negative 4 will be upgraded down up to be in the denominator. It means we have 1,000. So
I switched it, Mr. by accident.
نعم يا
I
اخوي.
did x over y. بالغلط.
طيب خلاص, do it now. Do it now.
Okay.
So sir, I got 8,888.
8,888.
Yes.
Oh yeah, I like this number, by the way. So we can change it into, just keep it in the calculation, but we can change it right now into 9.0 times 10 power 3. And this is the gradient, or the ratio in the gradient, and we have no measuring unit in that case. Type, could you do that for the worst line? Omar, what was your answer? Is it close to this number?
Mister, I got for the best fit, I got 12,500.
12,500. Okay, خلاص, keep it. Whatever. This is
Keep it?
yes, it's still around. Yani 9,000 or 12,000 is still around. It depends on the graph and the slope of the graph, but there is no big difference. It's around. Can anyone other confirm, like Ronak or Tulin, could you confirm?
Yes, sir. I got 8,444.
Yeah, it's very close to that. خلاص, keep it. So I will consider this answer, since I received it first, 8888, or it could be changed into 9 times 10 power 3. And because I got this answer, so I'm waiting, Uthman, I'm waiting for your worst line gradient.
Yes, sir, I'm solving it. Yes, sir. I got exactly 9,000.
Okay, that's great. So 9,000 here, it has also no measuring unit. So when I find the change between them, so I'm going to say change in G equal 9,000 minus 8,888. That gives you 100 something. 122, I think. So I just need to
Sir, 112.
112, sorry, this is my bad. 112. That means, the gradient could be, I will write the value for the gradient to make it a little different. So I will make it 8, 8, then 90, positive or negative 112. So it could be upgraded to something higher or something lower. Remember, there is no, even in the marking scheme, there is no real values or round values. We just find the calculation according to our graph. Now let's go to the last page, which is the most effective page. All the students can do the part before, and we could go like use your answer in A and C triple I, determine the value of S, include an appropriate unit. Remember, that D is equal to that number. So remember, at A it means we need to use this equation, which is, what is it? The gradient equal D over S, so we need to find S. And we are using D. So in that case, I could use this equation, which is S equal to D capital divided by the gradient. I will take this equation to the other page. Okay, good. So since S equal D divided by the gradient, that was easy. Again, so I could say right here equal D equal 2.20. It has been given, and it's meter. That's why the gradient has no measuring unit. So I'm going to write the gradient here. It makes your life easy, as you said. And the measuring unit for S, it should be in meter, since no gradient has no measuring unit. The gradient, as we just calculated, it's equal to 8890. So I'm going to write here 8890. And that means, S, remember, that S, it's the distance between the double slats, between the two slats. So it's supposed to be very, very small number. It depends on the diffraction grating itself. So could you do this calculation for me? 2.20 divided by 8890. That gives you approximately 2.5 times 10 power 2, 3, 4, 4. Any one of you, could you confirm, please?
Sir, I think it's -4, right?
-4, yes, you're right. Totally right. -4. That small number measured in meter, and this is the distance between two successive slits in the diffraction gratings. Right. Determine the percentage uncertainty in S. In this case, you need to find the absolute uncertainty to find the maximum value for S, and find the uncertainty. Then you can find the percentage uncertainty. So let's see. Any percentage uncertainty equal change in reading divided by the reading itself. I have S. So right now I'm gonna find this is 2.5 times 10 about -4. I'm gonna find S here, which is maximum. And in this case, I'm going to use D, which is maximum D. So, the D itself, it's maximum D. And the gradient, I will use the minimum gradient in order to find the maximum S. So in this case, I have 3 steps in order to find the percentage uncertainty. The first step, find S maximum. To find X maximum, it should be 2.20. Then I will take the maximum part, which is plus 0.02. This is only D, the maximum D, divided by the gradient. The gradient, since it's in the denominator, it should be the lowest number in the denominator in order to get higher S. So I could take 890, but I will use -112. This is the uncertainty for the gradient, -112. -112. So by this way, I will get the maximum possible values for S, and it's supposed to be bigger than S present in the previous question. Could you just tell me what's the answer here? Could be 2.22 divided by, I think, 9,002. For me, again, it is 2.47. 2.47. We can make it 2.5. Multiply by 1, 2, 3, 4. Negative 4. 10 power negative 4 meter. So this is the maximum value. Is it the maximum value? And then 2 divided by this one. It's supposed to be more. Is it 2 point? It's 2.2 divided by 8890. Okay, in this case, I need to change my answer here to be exact like the calculator. I will write it 2.47469. I think this is enough. Then multiply by 10 power negative 4. No need to make this a big approximation. So you're going to do like 2.47 times 10 power negative 4. In my calculation, I'm going to change my mind for this number. Sorry, for the product here. I just calculate it in the calculator. Let me calculate it again. 2.22 divided by 9,002. It's still a smaller number. I don't know how. Guys, is my calculation here correct? (2.2) divided by 88090. 247469. Okay. So right now it's 2.22, which is a bigger number. Divided by, this is my mistake. I need to subtract it, to subtract these two numbers to find the minimum. Then it could be 8890 minus 112. Then close the bracket. So the answer here, yeah, that makes more sense. So the answer here is 2.53 times 10 power negative 4. Can any one of you confirm? This is again M. Is it like that, Yasada?
Yes, sir, for the second one, sir, I got in 2 I ونفس الشيء.
Okay. So that means, the change in S, this is the absolute uncertainty, one before the last step, the change in S equal, you just need to use these two numbers minus each other. So I'm going to write here this number minus the previous number, which is 2.4. 2.47 469. Okay. For me, it is 5.9 times 10 power. I count 1, 2, 3, 4, 5, 6. 6 meters. Right? Now the percentage. So I'm going to use this 5.9 times 10 power 6 meter divided by S, the real value for S, then multiply by 100 in order to find the difference between them. So I will say this change divided by the reading of S itself, which is 2.47 multiplied by 10. This one, it's supposed to be 0.06 times 10 power negative 4. So I'm going to change it to 6.0 times 10 power negative 6. Okay. Then change in reading. I'm going to take this. This is the maximum. So change in reading could be the difference between them. 2.47 right by minus 6 by, okay, that gives me 0.000241, which is approximately equal to 2.41 times 10 power 1, 2, 3, 4. 4. This is also in meter. Now, this is the absolute uncertainty. So to find, and this is negative, to find the guys, I don't have a calculator here. I'm using my mobile, so I'm not sure if my answers is correct. Could you just confirm these two calculations? S maximum, is it correct? So just let me know what's the answer for S maximum. 2.2 positive 0.02 divided by 8890 minus 11.2.
It's right.
What it is? Tell me, let me know.
2.47
2.47 multiplied by
times 10 power negative 4.
negative 4. But how could be, the maximum could be the same like this number. انا مش عايز approximation, عايز exactly as
Yeah, I
flip.
got something else.
Oh yeah, please.
I
Help me.
got 2.53 times 10 to the power negative 4.
Oh yeah, that more sense because S maximum should be more than S. So I will depend on this. So what you have to do is, in order to find the uncertainty equal to the difference between them, the maximum and the average. So I'm gonna write here, it's 2.53 minus 2.47. Then I will take times 10 power negative 4 as a common denominator. 2 times 10 power negative whatever. Could you do that in your calculator again? 2.53 minus 2.
0.06.
0.06. So I'm going to write 0.06. And instead of using 0.06, I will use 6.0 times 10 power. What should I write here? Power negative?
Negative 6, maybe.
Negative 6. Okay. Okay. Right now, I have the uncertainty in absolute form. So what you have to do is 6 times 10 power negative 6 divided by 2.47 times 10 power negative 4 multiplied by 100. Once again, I will write it down here. The percentage uncertainty, it could be, the percentage uncertainty could be 6.0 times 10 power negative 6 divided by 2.47 times 10 power negative 4. Then multiply by 100. Could you do that in one step in the calculator and let me know what's the answer and then write it? خلاص. In my calculator, the answer is 2.429. So it could be 2.429. So I'm going to write it here. The percentage uncertainty, it could be 2.43%. Right? Then the last step, or the last 2 marks on the page, the experiment is repeated using the same double slit, but an unknown wavelength, lambda, of light. Anyway, the distance between 10 fringes, W, is measured to be, so we have a new W here. Determine wavelength, include the absolute uncertainty in your answer. Again, we need to repeat the idea about the absolute uncertainty, but first of all, let's find what's the wavelength from the law, then find the maximum value for the wavelength, then find the uncertainty, and an absolute is just the difference between them. So the first step is lambda, according to this law, what is it? Lambda, it's equal to PS divided by D. PS divided by D. Remember, in P itself, it's W over 10. So PS divided by D capital. So I'm going to go down here. Equal PS divided by D capital. Right? Since in P it's equal to W divided by 10, W here is 35. So I'm going to write W divided by 10. This is P, and I still have times X, and I still have times D. We repeat the experiment using a double slit but unknown wavelength. So the wavelength here is the unknown. And I have the same 10 frames. It means W, the new W is 35 divided by 10. So now let's see. For the wavelength itself, W is 35. Forget about the uncertainty right now. Then divided by 10. Then multiply by S. Take the value for S. This is the separation distance, which is 2.47 times 10 power negative 4. So you're going to write here times S, which is 2.47 times 10 power negative 4. Then divided by D capital. D capital, it is the distance between the diffracting grating and what is D capital here? Did you see D capital? Oh yeah, D is 2.2. So I'm gonna write here 2.2 times 2.2. Is it in meter? Okay, in meter, 2.2. This is to find the wavelength. خلاص, we got that mark, but actually they said include the absolute uncertainty. In this case, we need to find the maximum wavelength or the minimum. So for the maximum, I will use the same 35. It's just with the maximum value. So I'm going to say 35 plus 0.5 in order to increase the value of it. Then multiply by the maximum value for S. So I could take the maximum value for S, which is 2.47 times 10 power negative 4 plus 2.5%. Plus 2.5%, it means I'm gonna take the maximum value. So it's better to take the maximum value without further calculation. I will take the maximum value for S, which is present here. Yes, let me sign it. It's here. It's already made, right? So I will take the maximum value for S in order to increase wavelength. So the maximum value could be 2.53 times 10 power negative 4, then divided by D capital here. I need to take the minimum value for D capital. So it could be 2.2 minus 0.2. It could be 2.18. 2.18, correct me if I'm wrong. So it could be 2.18. And instead of 2.2, we subtract this. And in this case, you will get the maximum value for the wavelength. And you got already before, in the step before the wavelength, the difference between them is the absolute uncertainty. Hey, we have finished. And remember, still divided by 10. Here we have 10. This 10, which is 35 plus 0.5 divided by 10. This is exactly W. W divided by 10, which is P. بس خلاص. Keep in mind, I just want to say something here. This part, it is P, and this part, it is S max, and this part, it is D mini, in order to get wavelength maximum. Right? Whatever the calculation is, just put it, and that's it. خلاص. I think paper 5 right now is easy. I will not say any exam for paper 5 next Friday. I mean tomorrow. So it will be the next week, inshallah, Friday, not tomorrow, next Friday, after 7 days. It will be an exam for paper 5. You don't have to study that much in physics, theoretical, but you need at least to train yourself about 2 or 3 or 5 past papers from paper 5 by yourself. Maybe you're going to choose one you already made. So it will be easy for you. Guys, before we leave, I want to congratulate Ronak because she got a ranking for in a part of Saudi Arabia, which is eastern part Saudi Arabia, was the 3rd place in physics. That really makes me proud, and we mentioned your name many times in our meetings today and yesterday. So thank you very much, and keep the good working, and inshallah Allah bless you. And I hope that happens for all of you. You still have a chance during this session to get this ranking, and it will be a great memory for you and for your kids after that, and even for your kids. Try to do your efforts, and remember, Allah subhanahu, if you spend more time and if you work hard in something, there is some secrets. Even without teachers, you can reach to it. Even without any help from anyone. Once when you spend more time in something, there is some secrets. Maybe the teacher didn't tell you about it because he forgot this, or maybe it's not in the flowing of talking. But at least Allah will open these secrets for you, and you can do these things when it comes to science easier than the rest. So try to press yourself, encourage yourself, whatever the mean is. Give yourself some, what should I say, some gifts about the time and about the great future that may be waiting you. And inshallah, for all of you to get this ranking in this session. Thank you, guys. If you have a question, you can ask. If you don't have a question, you can leave. Thank you.
Sir,
Yes.
thank you so much. You are amazing. Thank you. It means a
Thank
lot to me.
Thank you. Thank you. Great. It's recorded, by the way, and I will share this part.
Thank you. Bye, sir.
Okay, bye. Thank you.